For any triangle ABC, we need to show that b minus c over a, this is equivalent to tangent of b over 2 minus tangent of c over 2 divided by tangent of b over 2 plus tangent of c over 2. So let us begin. So let's do one thing. Let's talk about the terminologies and the formulas that we'll be using to solve this problem. So here we consider a triangle ABC. The sides opposite to angle A, angle B and angle C are going to be denoted by the letters A, B and C in lowercase respectively. Now if we take the sum of the sides, so that's A plus B plus C, and divide it by 2, that's going to give us the semi-perimeter denoted by the letter S in lowercase. And then we have the half angle formula, tangent of A over 2, tangent of B over 2 and tangent of C over 2. Now using this, let's start a problem from the right hand side. On the right hand side, we have tangent of B over 2 minus tangent of C over 2 whole divided by tangent of B over 2 added to tangent of C over 2. Fine. Now let's use the value. So tangent of B over 2, that's given by the square root of, we have S minus A multiplied to S minus C whole divided by S times S minus B minus tangent of C over 2. So tangent of C over 2, that's going to be given by S minus A times S minus B whole divided by S times S minus C. This is going to be divided by, we have the square root of S minus A times S minus C divided by S times S minus B added to the square root of S minus A times S minus B divided by S multiplied to S minus C. Okay, so we will try to simplify this. So let's work with the numerator part first. So here what we'll do, we'll take the common denominator, which is going to be given by the square root of S multiplied to S minus B times S minus C. Then cross multiplying, the numerator part is now going to become, we have square root of S multiplied to S minus A S minus C whole square minus, we have the square root of S multiplied to S minus A times S minus B whole square divided by, coming to the denominator part, now we have a common denominator of the square root of S multiplied to S minus B times S minus C, and the numerator part is going to be the square root of S multiplied to S minus A times S minus C whole square added to the square root of S multiplied to S minus A times S minus B whole square. Fine. Here we will be factoring out the common factor from both the numerator and the denominator. And then this is going to leave us with, so let's pull out S minus C from the square root. We'll have S minus C multiplied to square root of S, let's write everything separately, times square root of S minus A minus, we have S minus B multiplied to square root of S times the square root of S minus A. Fine. This is going to be divided by, here we have division by S minus C multiplied to square root of S times square root of S minus A plus S minus B times square root of S times square root of S minus A. Now in the numerator part, we can take square root of S multiplied to square root of S minus A as the common factor. This gets multiplied to S minus C minus S plus B divided by, in the denominator we have square root of S times square root of S minus A. So here we will have S minus C added to S minus B. Fine. So here we can factor out the common terms from the numerator and the denominator. Now we have B minus C divided by 2S. So here we have 2S minus B minus C. Now what is 2S? 2S is simply A plus B plus C. So we have A plus B plus C minus B minus C. That leaves us with only A. That means in the denominator we have A, and this is exactly the expression on the left hand side. So we have successfully proved our problem So it's going to be true that for any triangle ABC, B minus C over A is going to be given by the following trigonometric expression.